Good morning students, this is your Prasanna ma'am from NEET World. Today we are here to discuss the most important topic, that is gene expression from the chapter molecular basis of inheritance. So this concept is very much important because many at times the questions are asked both for NEET and EAPCET. Okay. So yes, before understanding the regulation of gene expression, let us clearly understand what is gene expression actually means. What is gene expression actually means? So from a long strand of DNA, gene is nothing but the functional unit of inheritance. What you will call a gene as a functional unit of inheritance. So gene is expressed either in the form of phenotype. It is expressed either in the form of phenotype and genotype, or it can also show its expression by conducting some metabolic activity, or enzymatic activity also, or by conducting enzymatic activity also. So a gene can undergo any mechanism to express itself in any of these forms. So simple definition of gene expression lies as such, wherein the mechanism by which a gene is able to express itself in the form of a phenotype, genotype, or to conduct any metabolic activity or enzymatic activity in an organism, then it is called as what ma? Gene expression. As such, we have two types of genes. What are they? Constitutive genes and regulated genes. Constitutive genes are those genes which are continuously expressed. Though they don't require any inducer, to get activated for conducting gene expression. They are continuously expressed even in the absence of inducer. For example, the genes which are responsible for metabolizing glucose, or the genes which are responsible for conducting the process glycolysis in the organisms, those genes are what ma? Constitutive genes. They are continuously expressed. And in our Lac Operon model also, I gene which releases repressor, is continuously expressed. So this is also called as what beta? Constitutive gene. Regulated genes are those genes which require an inducer. These genes require an inducer to get expressed. Okay, they are not continuously expressed or constitutively expressed. So they are called as non-constitutive genes. For example, genes responsible for metabolizing lactose. Those genes like Z, Y, A genes. These are what ma? Structural genes which are present in lactose. They are metabolized once an inducer is present, okay, or in the absence of repressor, They are not continuously expressed. Only in the presence of inducer they are expressed. That is why they are called as what beta? Regulated genes. And next we have two types of gene regulation. We have what beta? Two types of gene regulations. One is positive gene regulation. And the second one is negative gene regulation. Second one is what beta? Negative gene regulation. Just give me a second. So in positive gene regulation, wherein the gene is expressed or the gene is activated either in the presence of inducer, or in the absence of repressor, That is why this expression is called as inducible expression. This expression is called as what ma? Inducible expression. if you take negative gene regulation is expressed or conducted either in the presence of repressor or in the absence of inducer okay, either in the presence of repressor or in the presence of inducer. Better you can use activator, or in the absence of activator. Here also you can take that term as activator. So from where are this repressor and activators are released? They are released from regulatory genes. They are released from where beta? Regulatory genes. And as this stops the gene expression, negative gene regulation will stop the gene expression. This will stop what beta? This will stop gene expression. This is said to be repressible expression. What is this called as? Repressible expression. Repressible expression. So now you might be getting the doubt, from where are these regulatory genes present? From where are these activator and repressor going to bind to the which region of gene, and how inducible expression is seen and how repressor expression is shown. So if you take a transcriptional unit, where we learnt that the transcriptional unit includes promoter, structural genes, and terminator, promoter, structural genes and terminator. So if you take a Lac Operon model or any other model, promoter is followed by operator. Promoter is followed by what ma? Operator. To promoter region, always RNA polymerase will bind. To promoter region, what will bind beta? To promoter region, always RNA polymerase will come and bind to the promoter region. Once RNA polymerase is bind to the promoter region, then if activator or inducer attaches to the operator region, for example, activator is attached to the operator region, then the gene expression is done. The gene expression is done as the gene is regulated and it finally gets expressed. If in case in the presence of activator, if repressor is coming and binding over this operator region, then even though RNA polymerase binds to the promoter region, the gene is not regulated and it will not show its expression, as the gene expression is blocked by the repressor which is attached to the operator region. Now from where are this activator and repressor being released? Activator and repressor are released from these regulatory genes which are far from the promoter region. Though they are far from the promoter region, they release this activator and repressor and regulate the gene expression. Is this clear beta? Clear, right? Both positive and negative gene regulation. Now we will look into the gene regulation pattern both in eukaryotes and prokaryotes. If you look over here, in eukaryotes, gene is expressed at 4 levels. In eukaryotes, gene is expressed at 4 levels. At first level is the transcriptional level, where from the double stranded DNA 5 prime to 3 prime, 3 prime to 5 prime, of which will act as a template strand. Of course, this acts as a template strand. Taking this as a template, mRNA is synthesized from 5 prime to 3 prime direction. So this primary transcript, at the formation of primary transcript, a gene can be expressed. This primary transcript is a combination of intron and exon. This primary transcript is a combination of what beta? Intron and exon. So these introns are spliced. These introns are spliced, right? These introns are spliced. So at splicing time also, a gene can be expressed. What is this? This is a spliceosome. This is a spliceosome. So at the splicing time also, regulation of gene can happen. Third is after capping 5' capping and 3' polyadenylation, 5' capping by methyl guanosine and 3' polyadenylation, when this mature mRNA is transferred with 5' cap and 3' polyadenylation, when this is transferred from nucleus to cytoplasm, this is transferred from nucleus to cytoplasm, also a gene can be expressed. At this time also a gene can be expressed. So at 4 levels beta. One is formation of primary transcript, a gene can express in eukaryote. Second is at the time of splicing. Third is while transporting the mature RNA from nucleus to cytoplasm, and fourth is at translational level, that is at the time of protein synthesis. Even at this region also, at this time also, a gene is expressed in eukaryotes. You will understand more clearly when you look into a diagram. So here if you see genes on DNA, first they undergo the transcription. After transcription, see, during the time of primary transcript, a gene can express. From here, after splicing, mature RNA, mRNA is formed. Even at this time the gene is expressed. From nucleus to cytoplasm is transferred. Even at this time it is expressed. And finally at the formation of proteins, a protein chain, even at this level the gene is expressed. So this is all about the gist of gene regulation in eukaryotes. We need to learn more clearly the gene regulation in prokaryotes by Lac Operon model. This is a small information, you can take a screenshot of it and refer it later. So if you take a Lac Operon model, this is given by Francis Jacob and Monod. Wherein Francis Jacob is a genetist and Monod is a biochemist, right? So yes, here in Lac Operon model, as we have already discussed, that promoter is followed by I gene. Promoter is followed by what ma? I gene, and I gene is constitutively expressed. Here I gene will release what ma? Repressor mRNA. I gene will release repressor mRNA. This repressor, in the absence of lactose, it will bind to operator region. Actually, why a bacteria need lactose? If you take a bacterial culture, bacteria to grow, it needs sugars, either in the form of glucose or in the form of lactose. As glucose is monosaccharide, if glucose is given, it will directly take glucose. If glucose is not present, then you will give lactose. Lactose is taken by the bacteria. This lactose is a disaccharide, right? Lactose is a disaccharide, wherein this is break to glucose and galactose. This process is conducted by gene regulation. How that is happening, we will look into it. So when lactose is added into a bacterial culture, this lactose will go and bind to the repressor region. Now repressor is holded in the cytoplasm. There is nothing to block the process of gene expression, as repressor cannot come and reach the operator region, because lactose is combining with repressor. Inducer can either be lactose, or allolactose. It can be either lactose or allolactose. Once it is binded with the repressor, it cannot go and bind to the operator region. Then in the presence of inducer, the gene expression is happening. When lactose is not given, then there is nothing to bind with the repressor. Then of course repressor will go and bind to the operator region. Then the complete gene expression is blocked. And this we can take an example of negative gene regulation in the presence of I gene that is giving the repressor. Here it is what negative gene regulation. What is positive gene regulation? If you look here, promoter to this RNA pol will bind, then I gene will release the mRNA, repressor mRNA to this repressor. When we add lactose, when lactose is present, to this repressor, inducer is coming and binding either in the form of lactose or allolactose. Then the gene expression starts. How it is starting, you see. Z gene codes for beta galactosidase. What does beta galactosidase do? Beta galactosidase will cleave the disaccharide, that is lactose, into glucose and galactose. What does beta galactosidase do? Beta galactosidase will cleave the disaccharide, that is lactose, into glucose and galactose. Next, Y gene. Y gene is coding for permease. This permease will increase the permeability of the sugars into the cell, okay, or into the regulation part, okay. It will increase the permeability. Of lactose into the cell to make the gene expression more efficient or effective. And lastly, A gene. This is the third structural gene. A gene is coding for what? Trans-acetylase. Trans-acetylase will add acetyl-CoA group to galactoside or lactoside or glucoside, so that these sugars will not re-enter the path of gene expression. Why is the acetyl group added to these sugars, so that they will not re-enter the path of gene expression. This is the activity of Z, Y and A gene. Very, very important, students. What is Z gene coding for? Beta galactosidase, helpful for cleaving lactose into glucose and galactose. Y gene is coding for, permease. Permease will increase the permeability of lactose into the cell. A gene is coding for what? Trans-acetylase, wherein it gives the acetyl-CoA. It adds acetyl-CoA to galactoside, lactoside and glucoside. So they will not re-enter the gene expression again. They will not re-enter this pathway again. Clear with all this? Clear? So this is all about Lac Operon. As there are multiple structural genes expressing many polypeptides, expressing many different protein chains, or expressing multiple expression is seen over here because of the presence of multiple structural genes. So this expression is called as what? Polycistronic expression. Polycistron. Only observed in prokaryotes. This is only observed in what, beta? Prokaryotes. So this is all about Lac Operon. What happens in the absence of inducer? In the absence of inducer, this is a negative gene expression or negative gene regulation. In the presence of inducer, it is a positive gene regulation. If you want to have a look at it, you can also go through the concept. Just now whatever we have discussed is elucidated here. You can go through it, or you can have a screenshot of it. And lastly, how Lac Operon is working. Just now we have discussed that is present over here. So in Lac Operon model, the questions will be asked as such. What is the constitutive gene? Then your answer should be I gene. What is the constitutive gene beta? I gene, which is continuously expressed. RNA polymerase will bind to which region? To the promoter region. To operator region, what is binded? Repressor. Repressor binds to operator region only in the absence of inducer. Z structural gene is coding for what? Beta galactosidase. Activity of beta galactosidase is what? To cleave the disaccharide into galactose and glucose. Next comes Y gene. Y gene is coding for what? Permease. Activity of it is to increase the permeability of lactose into the cell. Next, lastly, A structural gene is coding for what? Trans-acetylase. What does trans-acetylase do? It will add on the acetyl-CoA groups to glucoside, lactoside, galactoside, so that they will not re-enter the same mechanism. So this is all about Lac Operon model. Coming up, we will go with very many interesting topics and most crucial for both EAPCET and NEET. Thank you.